It's not discussion. Hello, let me send this message. One minute, let me send this message so that a lot of people have not logged in. All right. So we are back. Let us do the actual test now. The test we'll be doing this semester, the type of hypothesis test we'll be doing is called the Z-test for the mean. Z-test for the mean. There are two methods, the traditional method and the p-value method. Okay, I think you can see the screen. Yep, see it. Let's start with the traditional method. Under the traditional method, this is what we do. We state the hypothesis and identify the claim. I've already shown you how to state hypothesis. Excuse me. Then we find the critical values using the table. Here we use the table of normal distribution. We did normal distribution when we are doing a normal probability distribution. And we also use the table of normal distribution when we are doing a confidence intervals last week. Then we compute this test value. To compute the test value, we use this test statistic here. Okay, there's the formula here. Then we make decision to reject or not reject null hypothesis. So in this case, since it is the traditional method, we use our critical value to make that decision. Then we summarize the results. So the decision criteria is this. We reject null hypothesis if and only if the calculated value, that means if and only if our answer is equal to or greater than the critical value. So if our answer is less than the critical value, we do not reject null hypothesis. And this is how do we get that answer? We use what we call the test statistic, which is Z equals sample mean, which is S bar minus population mean, divided by standard deviation over root n, where means see S bar is sample mean, mu is population mean, delta is population standard deviation, and n is sample size. Let us see how this works. At least one example will help you understand this. Okay, look at this question here. It said, that a researcher report that the average annual salary of all assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, test the claim that the assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. Now, you say that they earn more than. Now, they get a sample of 30 assistant professors and has an average salary of 43,260, which is bigger than this. So somebody might say, already we know that this answer is they earn more because the average for these 30 samples is bigger than 42,000. So what's the point in testing? Well, of course, you know that the 30 assistant professors is very small compared to hundreds of thousands assistant professor. So it does not represent the population really. So that's why we still need to do the actual test. Yeah. So to do that test, for some reason, this is not allowing me to put my course. Okay, I'll use a different approach. All right. So we have its solution here. And the solution for this, we state our hypothesis, identify our claim. Why is this not allowing me to put this in here? Okay. Is it the formatting? Clear formatting. Oh, excuse me. Undo all. Okay, just don't mind me. All right, let's see. I don't know why it's not allowing me to put my cursor here, but I'll figure it out. Just give me 1 minute. Okay. So we have the solution here. So let us state our null and alternative hypothesis. Before that, let me make this, okay, make it 16 so that we have enough room. HO and H1. That's the first thing you do to state the hypothesis. And given that this is we're going to use a traditional method. Okay. We have this HO. It says a research report that the average annual salary of assistant professors in the year 1997 is more than 42,000. So more than means greater than, and you can only use greater than here. Okay. So we have mean. I'm going to insert mean. Mean is greater than $42,000. And that is the claim. He's making the claim. And like I explained to you, the alternative hypothesis always has the opposite of this. So we can say each of the hypotheses, no alternative, they say the opposite of what the other one is saying. So this one should mean less than 42,000. But we can't use less than symbol in the null hypothesis. You can only use less than or equal. So you have mean. So you can only use less than or equal to yes. So less than or equal to 42,000. 42,000. So the first thing you do when you are solving a hypothesis problem is to state null hypothesis, identify null and alternative hypothesis, and identify your claim. After that, you do what? You find the critical values from the table. Find the critical value. So that's the next thing we need to do. Let's find the critical value. What's our alpha? So alpha is our alpha here is 0.05. That means your chance of committing type 1 error is 5%. So our critical value, okay, to find the critical value, it says greater than, remember this is like right there test. So you can draw the chart under here. Let me see if I can draw this chart here. and make the chart. From here, all right, let's see. You can make the chart. I mean, this is 0 here. You don't know what the number is, so we can just put the line. Then you can make your chart. So then from here, okay. Now put your center line just 0. So right here. So I'm gonna move this 0 down backward. Give me 1 minute. Let me get 0. Okay. This 0 can we move back? Okay, good. Now, so it's a greater than. So you gotta be on the right side. From this one, see greater than. You don't know the number, but that number has to be here. So it's a greater than. It's gonna be greater than this. Okay. So we share it. Okay. And then share it. And then, so you gotta be somewhere here. That's what it's gonna be. Now, to critical value, we have equal. Now, remember, when we are doing normal distribution, I say that when it's at the tail, you subtract the answer from the 0.5 and then find it on the table. And let me explain for you more what I mean by that. If you look at our procedure table here, procedure table, okay? I'm gonna open it here so that you can take a look at this. Procedure table, let me show you the table right here. So you can see that when it's at the tail, it says look up the z value to get the area. Subtract the area from 0.5. You can see this one is the diagram that looks like what we have here in our chart. See? So that means we're gonna do 0.5 minus 0.05. That's this one here, alpha. And that gives us 0.5. We have it's a calculator. Yeah. Our calculator is somewhere. Okay, Desmos. Okay. Calculator. Now share it. What is my calculator? All right. It's right here. Okay. Say 0.5 minus 0.05. Sorry. 0.05 gives 0.45. 0.45. So we go and put it in 0.45. Okay. 0.4500. Now, this is what we know. So we look for this on the table of normal distribution. If you don't see the number exactly, we choose the number that is closer to it. So I'm taking to the table of normal distribution. Yeah. Take a table of normal distribution so that we can find our 0.4500. Okay. So I'm looking for it. I think I opened so much pages that some of them are missing. Okay. I'm gonna find it. The table of normal distribution is right here. So I'm gonna share it with you. Now, 0.4500. Remember what we are looking for is 0.4500. So look at it, ignore the decimal points and look at it at 4500. So that you can just look for numbers closest to it on the table. 4500 have 4591, have 4495, and 4505. They are equally close. And I'm going to show you what I mean by that. 4495. If you look at the calculator, 4500 minus 4495 is 5 points away. Now, if we try it with the other number that is closer, say this one here, 4505. 4505, okay. So we have 4505 minus 4500 is still 5 points. So they are equally close. So what we do in that case is to choose, if they are equally close, we choose the one that is bigger. So that means this one, 4505. Follow it to the left, 1.6. Up, 5. See? If you follow it to the left, see this is the Z right here. If you follow this to the left, 1.6. Up is 5. So 1.65. So it becomes 1.65. 1.65. So the critical value is 1.65. And that is what you will have here. Okay. 1.65. See? So when you're testing hypothesis, remember, you state your hypothesis and identify the claim. We did that right here. Now, next is to find a critical value from the appropriate table. We just did that now. This is critical value right here. See? So next now is to run the test using this formula here. Okay? Yeah. And so let us run the test. All right. Remember that it says here that the mean, the average annual salary is 42,000. So our mean is 42,000. So you can put it here. Let's put everything we need to run the test. The mean equals 42,000. I'm going to make it bigger because this is too small. 42,000. Okay. Then the standard deviation, make sure I've seen this. Okay, good. Standard deviation is what? Is 5,230. The standard deviation is 5,230. So we insert it. 5,230. The standard deviation, which is right here, is 5,230. Okay. Again, I have to make it big so that we can see it clearly. Okay. Another thing we need is a sample of 30 assistant professors. So N is 30. Yeah, again, I have to make it big. I don't know why it's doing all this problem tonight. Okay. Now, what else do we need? It says, out of this 30 assistant professors, the mean salary is, for the sample mean is 43,260. Now, this workbook will not allow us to get the sample mean character. So I'm going to get it from the other workbook. I'm going to put it there. And then we'll copy it and paste it on this one. Okay. Let's see. For the 3,260 going to be, or I can just use let me go and put it on that 43. Let me write it down. X bar. I'm gonna put this side. X bar for the 3,260. So I'm gonna go here. X bar. We have insert again. X bar is have 43,260. Okay. Make it big. And then copy it. Okay. Then go to that our main workbook and paste it there. Okay. All right. 43,260. So this is what you need. And the formula we need to calculate it is the z equals the x bar minus mean divided by standard deviation over root n. So I'm going to write this in. So remember what we need here. We need this. So let me write it down. S bar is this. Mean is 42,000. Okay. Standard deviation is 5,230. X bar, I have it already. N is that. So it will not allow us to put the formula here, the character. So I'm going to take you to that workbook, put everything in the formula, and then bring it back here and paste it. So Z, the statistic Z, okay, Z equals, it's in the equation, okay, equation. We have this, X bar, okay, minus the mean. Mean is divided by standard deviation over the square root of n, which is this. Which is now, I can plug in the numbers now. We have, make sure I've seen this. Yeah, I've seen it. I can plug in the numbers now. Numbers, S bar is 43,260 minus 42,000 divided by standard deviation of 5,230 over the square root of n, the square root of 30, because there are 30 assistant professors we are selected. Okay, and that gives us now, you can get the answer for this. Looking at the, use the calculator, which is the Desmos. So putting this in the calculator and making sure you are seeing it. Okay, you have S bar is 43,260 minus the mean of 42,000. Okay, divided by standard deviation of 5,230 over the square root of 30. Okay, 1.32, approximately 1.32. So answer is 1.32. Oh, excuse me. Answer is 1.32. 1.32. Which now we can now copy this and paste it in into our main workbook. Copy this, go to our main workbook and paste it, then we make our decision. We have run the test. See, this is the result. Test statistics. The next thing now is to make our decision. Okay, remember, when testing hypothesis is step by step. So we have stated the hypothesis and identified the claim. We have found our critical value. We have run the test. Now it's time to make decision. Now, see our decision here. The decision criteria. If you remember, it says reject the null hypothesis if the calculated value is less than is equal to or exceed critical value. That means if our answer is equal to or more than the critical value, we reject. But otherwise, we don't reject. So our critical value is 1.65, right? See, critical value 1.65. Okay. Critical value Z alpha. Z alpha is a critical value. It's an alpha, right? Alpha. Here is we found it to be 1.65. 1.65. 65. So I'm gonna make these things larger than this, because they should be. Okay. Make them bigger than that so you can see it clearly. Okay. Okay, 1.65. Okay. All right, let me see why it's like that. So 1.65. Now, our calculated value is Z. Calculated value. Value. Okay, which is just Z. Calculated value is Z. Maybe let me make it big. I don't know why it's keep changing. Z equals, our answer is 1.32. 1.32. Now we can compare them. You can see that our answer is smaller than this. If our answer is bigger than the critical value, we reject. If it's smaller than critical value, we don't reject. So do not reject null hypothesis, because 1.32 is less than the critical value of 1.65. 1.65. So don't reject. So, and you can even see it here. This is 1.65. And if that is 1.65, so our answer is just here. Our answer is 1.32. So you can see it right here. It could be 1.32. So you can see that it does not fall in the rejection. It falls somewhere here. See? Somewhere here, not in the rejection region. So that's why I see when we say that it doesn't fall in the do not reject, that means it doesn't fall in the rejection region. So we have it here. We have made our decision. Do not reject. Then let's conclude. Conclusion. Okay. See, there is insufficient. Now you say do not reject hypothesis, not HO. That means we are not rejecting this HO. That means this claim is not correct. If you are not rejecting HO, that means we are accepting it. That means this one is bad. So we mean that there is not enough evidence to support this claim. So there is insufficient evidence to support the claim. Insufficient evidence to support the claim that that the salary, the average salary of the assistant professors in 1997 is more than 42,000. Because that's what it's saying. There is insufficient evidence to support the claim that the average salary of assistant professors is more than, okay, this is the claim right here, that the average salary of assistant professors is more than 42,000. Okay. Any question on that? Any question? Okay. So there's no question. So again, this is the traditional method whereby we state the hypothesis and identify the claim. We find a critical value. We computed the test value. We made our decision, and we summarize our results. So, which is that the average salary of assistant professors. There's insufficient evidence to support the claim that they make more than 42,000 in 90s. They made more than 42,000 in 1997. Now, this is the traditional method. Now, when we come back, we're going to come back one more. We'll come back, we do the p-value method for testing hypothesis. And then we now conclude by testing hypothesis for a small sample. Any question? Any question, guys? Hello? Can you hear me?
No questions.
Okay. So let us time us. I'm going to time us out so that we come back after 10 minutes to complete the class. Okay. So wait for 10 minutes and then log back in to complete. I see you get back here in 10 minutes. Okay?
Okay.
All right.